We want to find the acute angle between the lines shown. R is 241 plus T 3 minus 1 2 and R is 5 6 minus 4 plus S 1 minus 3 3. When considering the angle between the lines, the only important thing is going to be the angle between the direction vectors. The direction vectors give us the direction in which the line is going. The fixed points play no part in this. Therefore, the angle between the two lines will be the angle between the two direction vectors. So we're after the angle between these two vectors. We know the definition of the scalar product is that A dot B is the modulus of A times the modulus of B times the cosine of theta. We've seen this before. Therefore it follows that if we have 3 minus 1 2 and we dot this with 1 minus 3 3, this will be equal to the modulus of the first vector, which is the square root of 3 squared plus 1 squared plus 2 squared, times the modulus of the second vector, the square root of 1 squared plus 3 squared plus 3 squared, times the cosine of the angle between the vectors. We can calculate this. 3 times 1 is 3, minus 1 times minus 3 is 3, and 2 3's are 6. This is the root of 9 plus 1 plus 4, which is 14, times the root of 1 plus 9 plus 9, which is 19. So the cosine of theta is going to be 12 divided by root 14, root 19. This calculates to give us 0.735 and so on. So for the angle we do inverse cosine of this number or shift cosine, giving us 42.6 degrees, correct to 3 significant figures.